So for loading a fish image, we use load image, and we give it the file name fish1.png. And now we have the fish image for drawing. So just to test, we translate to the center of the screen, then draw the fish. So translate width divided by 2, height divided by 2, and then we use image function to draw a fish at 0 and 0. So we move our brush to the center of the screen and draw the fish out. And we can run it. So where's my fish? Oh, and you should draw the background before you draw everything. So now I draw a background. And maybe the fish image is too big, so we specify the fish image to be 300 and 200. Yeah, so we have the fish right now. And most of the time when you are drawing a fish, drawing an image, it is default on the left top corner. So just like rectangle mode, just like circle ellipse mode, you should translate to the image center to let them align to each other. So we use image mode, center, to get the image to align to the center. Yeah. So in this one, most of the time when we are drawing image, it's not like just calculating those points and positions. We can get something rotating. We have to translate all the canvas. So you can imagine that if you want to draw something on your canvas, draw like a waving fish, you have to rotate your canvas a little bit and place it on the canvas and rotate the canvas back, so it'll be tilted. So something just to test like this, so rotate like frame count divided by 10. We use an adding number to the fish and it'll start to rotate because frame count is increasing every time. If you are interested, you can console.log frame count divided by 10. Oh, so you can see that the frame count divided by 10, we use it as a degree and assign it to the fish. And then for a little like advanced technique, we can map those like divided by 10. It is actually mapping a larger number, like from 0 to 100 to 0 to 10. I should wait a second. I should connect to my iPad, like a Blackboard. So if you have, I recommend you guys to code along, like you don't get lost in the rest part of the class. And we can so is everyone okay till now? Yeah, okay, sure. So we open QuickTime. Player. Start iPad. Okay. So now we are going to let the fish like waving like this. So we have a fish here, and you want it to like move like backward and forward and rotate a little bit using this point. So how we should assign to the degree is that we want the degree like waving through time. So if we have a number just like frame count that increase by time, we'll get a degree like this, and our fish will just like keep rotating clockwise and never come back, clockwise and clockwise, because the degree are always increasing. But how can we map this number to something like this waving? We can imagine that our time, we're kind of like sampling those points based on time. So like this is frame 1, frame 2, frame 100, frame 1000. We want to get the point actually depends on the actual point, the intersection of this wave line. So this wave, it's called sine, a very painful math word, and we just want to get the numbers, the height of the point. in this figure. So how we can get this is like we give it like sign 1, and p5.j sign will return the value of this height to us. And if we give it like sign 1000, we will get the point here, and we will get the height here. So if we just use let the new degree, so we just var degree dg equals sign frame count divided by 10, sign frame count, and we can use this degree as a degree for drawing the image. So we rotate for this degree instead. We will get the fish like waving up and down, up and down. And so you can manipulate this image by canvas rotation, canvas scaling. So if you want to make it smaller, just like scale 0.5, we'll get a smaller fish. And so after you manipulate those images, remember to use push and pop. So always revert the changes you've done to the canvas, so you will not affect other objects on the canvas. So like push and pop. So if you don't do push and pop, and you draw a rectangle afterward, like rectangle 0, 0, 50, 50, you will get a rectangle in the center of the fish, and it is rotating with the image because the canvas rotation is not turned back. But if we like move it out of push and pop, it saves our state before we translate the canvas. So if we draw a rectangle on 0 point, it is actually drawing at the corner, the original starting point. Okay. So now we will make the fish following, start from the mouse position. So the next step, we make canvas a little bigger, like 800 and 600. And then we want, wherever I click, I want the fish to like appear on that position. So I use function, mouse pressed, and then I want to set the fish position based on mouse. So that's why we use a variable, and we can use like X and Y directly. So we can like var fish X and var fish Y. So it is always easy to like put a lot of variables here, but it's hard to manipulate and control those variables names, and it's also painful to when you have to like correct those variables names at a time. You have to check through all of your codes. So I also recommend you to wrap like those informations when you're sure they are all belongs to the fish. You wrap it inside an object called fish. So we can make a fish, and we can wrap it inside an object. An object contains the position, so give it P as position, and P is also another object containing X is 0 and Y is 0. So whenever we want to get the position of the fish, we use fish. So we cancel the translate to the center, and we draw the fish at fish.x, .p.x, and fish.p.y, and we draw fish.image. So we also store the image as an object, and it is null by first, and after we preload, we can just set it to load image. So what is inside our JS code? We get a fish object, so we can print out fish, and we can see that fish is an object containing two variables. One is image. Image is the image data we loaded from P5, and then we have fish.p. P is the position of the fish. It is 0 and 0. So now we can like just set the fish.p. So if you use console and you set it like fish, we just disable the console log. Okay, so we click inspect and console. we let fish.p plus equals 10. P, okay, again. So fish.p.x plus equals 10 plus equals 10. You'll see the fish is moving to the right side of the screen. So now we want to set the position to the mouse. So whenever we press the mouse, we set fish.p.x equals mouse x and fish.p.y equals mouse y. So we click it, but you can observe that it's a little weird because it is always rotating for around the corner of the screen. So the order of the rotate and translate will be, you have to translate to that point first and then rotate. It is the better order of that. So rotate for translate first. So the original 0 point is here, and we want to translate to the fish position first and then rotate for a specific angle. So that means we have to translate to fish.p.x. So we translate to that position and rotate at a certain angle. So it'll around that angle, but not around the corner. And then we draw the fish at 0 and 0 because our new 0 point is translate to that point. So we can let the fish swim to this position. And some of you may making some creatures swimming around the screen, and you want to have a target destination, and you don't want the fish to directly appear on that position. You can use a technique called lerp. So what you can use as lerp is when we press the mouse, we set the target, but we didn't change the fish position directly. We wanted to lerp a little, originally we are here. From here, we want to translate to here, and you want to get a percentage between these 2 points. We want to get 40% of the distance toward this point. You want to get this one. So you can use lerp, and how you can use that is we set a new set of variables called target p. It's also an object inside fish, and it contains x and y. And then whenever you press the mouse, you set the target p to mouse x and target p.y equals to mouse y. And then what will change is that we set the target inside fish, so you can check for console and check out that fish. When we click on the screen, fish is actually contains p and target p. Target p is wherever we click on the screen. And then we want this position value to move a little slowly toward the target. So every draw frame, we let fish.p.x equals lerp. And you can check out the p5.js editor. So p5 reference, and we get lerp. So lerp is getting to value. You get the start value, the end value, and you specify the percentage. And you can get the final value of that middle point. So we want to lerp fish.p.x toward fish.targetp.x, and we want to move it 0.2, a little bit, 20%. And we also do that to y, and you can get the fish swimming toward that point. And you can make it a little slower, so we just move 10% of the distance at a time, so it'll be much more slower. And also for controlling the angles of the fish, want to make it a variable on the fish object, so we make a new value called angle equals 0, and we rotate angle. And then we set the angle every time when we draw the fish. So we set for all the data manipulations. So fish, data, changing. We put it here. And we set fish.angle angle equals sine frame count divided by time. So, what's that? Fish.angle. So the advantage of that, separating the data and the actual drawing function, is that you can see that in push and pop, we only like manipulate the canvas and draw something based on the original data. But we gather all the position and angle change here, so you can, it's much more easier when you separate your logic and your drawing functions in two parts. So now we have fish. Okay. So now we want to make multiple fish that will swim like toward the right side of the screen. So first we make it, we add velocity to this object. So we want fish to move like toward the right side. We want the position to change by time. So you can imagine that our fish position will add one, and add one by time, and want to log that velocity inside of our object. So we add velocity and give it x. We want it to move to the right side, so give it 2 or 1, and y is 0. So now we can get the velocity inside the fish object. So if you want to move the fish, you can just like fish, and want to cancel the mouse thing, and we let it directly pointing to mouse because we wanted to swim and generate a new fish on our position. And then we add fish.p.x plus equals fish.v.x. So we want the position to add velocity, and also y add equals velocity. So wherever we click on the screen, the fish will start swimming, and we can set the velocity to like random 10. Yeah, so when you open the sketch, you will get a different velocity again and again. Okay. So we can also check for like when fish swim outside of the screen, want it to come back. And I think most of your works, you want like things inside your screen. And you want when they come out of the right side, it will come back from the left side. When it comes out of the top side, it will come back from the bottom side. So how to achieve this is just like manipulating your positions. So if fish.p.x bigger than width, we just like minus width. So fish.p.x minus equals width. So we will take a fish from the right side of the screen back to the left side of the screen. So when it's over the right side, yeah, it'll come back from the left side. And then in the next step, we will add multiple fish in our screen. So now we know we can wrap those in the objects. Actually, we can make those objects as an array. So we can iterate that array of objects and draw out every fish on the screen. So how to do this is we make a new custom function that's called addFish. Function addFish. And in addFish, we specify the image, we specify the initial position for those fish, and put it inside an array. So do you guys all know about arrays? Like familiar with arrays? Okay. So we make a new fishes array. So var fishes, and we var an image storing the fish image data because we want to use it again and again. We don't want to load it every time. So in preload, we let fish image equals to load image fish1.png, and we assign fish image to this image. Okay, so we want to make a new fish object. Whenever we click on the screen, we add fish, and we just like making this new object, and we want to add it but the position of the mouse x, and mouse y. And after making this object, we make it like a temp fish because we want to add it inside an array, and we make fishes an empty array to store those objects. So for fishes, we add the temp fish objects inside fishes. So fishes.push temp fish. Okay, so whenever we run the addFish function, so when we mouse pressed, we run add fish, and we check for add fish, like click, 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 and we can get fishes. It's an array that contains 4 objects, and each object are just like the original first fish. So now we have an array of objects. We just have to draw out those fishes and based on their own data, and we can get multiple fishes independent on the screen. So we loop through the fishes. So for var I equals 0, I smaller than fishes, dot length, I plus plus, and we can get fishes I. So we get the ith of the fish, and then we draw that out. So we can call our drawing function here and put it inside and replace all the fishes as fish I. So most of the time I will make a temporary variable because we make this fish variable drawing method before, and I don't want to change that variable name at all. So I will make a temp variable like let fish equals fishes I. So what we will do in let is actually just working in the curly brackets. So outside of the curly brackets, it's not working at all. It's not a variable. So we use let to generate a space storing the fishes, and we pick a fishes from the fishes array and then put it as a fish object, and we can manipulate that fish object. So we are just like, we have an array of fish, and that is called fishes. And whenever we are like drawing the screen, we pick out one by one and draw them on the screen, and we save this fish temporary as a variable called like fish, and we draw those fish. So in this case, whenever we click on the screen, we can make a fish on the screen. But it's a little boring because we didn't change the position at all. So the same technique also works. Because we named that variable as fish, we store it in the temp variable. We can move all the positioning manipulation inside. So we manipulate their position and then translate and draw them. So whenever we click on the screen, we can make a lot of fish. And also this is another technique. Like you can see that because we're using the same frame count, we're dividing by the same number. It's kind of boring because they all have the same rotation. So what I will do most of the time, I will generate a random number when I'm constructing that object. So I generate a random ID equals random 1000, like whatever you like, 10,000, 1000. And then you can add this random ID to the fish angle. So when you're calculating the angle, imagine that you have different fish. They all have the sign of frame count is always the same, but if you add a random sample point, so the first fish is sampling at 100, and you add, when you are sampling the second fish, you add like 50 to this, so you are sampling this point. So you can imagine that they are at the different position of the point. And also you can think as another point. So you can imagine that we are using the random ID just to offset this wave. So we offset this wave 0 by random ID. So if this one is 100, we offset it a little bit leftward. And we can see that although we are sampling the same point on the wave, we get different values. So they are in different cycles of the rotation. Okay. You guys look frustrated. Are you all right now? Okay. Okay. So we use fish.random ID. So what we were doing is like they will like rotate in different cycle, kind of fun. And you can also generate a random scale. So scale equals random. 100, like 1. So we can scale the fish before we draw the fish. So fish.scale. Okay, so we have different scales of fish. It's kind of fun. It's a little big. It's fun. Okay, and we can we just change the background to black. So instead of a sign, you can imagine that if we have a continuous random number, like it move like this, like somewhere upward and downward, just like something like this. If we assign this continuous random number, the fish will rotate in a different pattern, non-predictable, more like energetic, more natural. So most of the time when like students come to us, they will like directly replace this sign by random, and that will cause like scaring effect on the fish. Random times 10. So we'll get something like this, and they will make it smaller. They're thinking like, if I make it smaller, they might be similar, and this fish will rotate more smoothly. So this is not the case because random always generate a new number based on nothing. So we cannot predict. You can imagine that random is getting a random point on this line. It's not continuous. So if we like scale up this part to like 1000, the continuous line is still continuous and they will be similar, but the random point will not like have any relationship between those 2 points. So if you want to assign random numbers or random rotation, please use noise. Noise is a predictable random, and it's just like they give you a random line and you can sample by a static number. So if you sample like at 100 at noise, it'll be unpredictable. It'll be a random number, but whenever you use 100 to sample the noise, it'll be the same value. So it is the magic of the random, of the noise. So we get like noise frame count divided by 10, and you can see that it's continuous. And if you like divide this frame count by a larger number, that means we sample on this line a little more slower. So you can imagine that it is rotating more slower. What is that? Okay. So it is rotating a little smaller. And the range of the random variable is from 0 to 1. So you might use the technical map. So we map this noise number from 0 to 1 to -5 to 5. I don't know what it would be like. Yeah. And also you can use the same technique as the random ID as the sample point. So you can add like fish.random ID on the noise. So it'll rotate in different directions. And we can give it different velocity also. So we can give it a random number from 0, 3 to 5 or 1 to 5. Okay, so now we have a lot of fish dying on the screen, and we can make it smaller during the time. So we get the fish. So when we manipulate data, we put them together. So you can observe this part. So always make sure you make clear comments about your code. And this is changing the fish position and scale and rotation, something like that. And this part is drawing out this fish. And so we make it. What do we want to do right now? I forget. So we have different velocity and we have different fish. And then I forget what I'm doing now. Yeah, so is there any question till now? Like making an object? Yeah? Yeah, sure. I will save this code and send it to you. Oh, okay. So what I want to do is to load a different fish image, and we want to use the same object at the time. So we want to load jellyfish, still some kind of fish, but it's not fish. Which one? A little bit slower. Okay, sure. Okay. Okay. So when loading the image, that's the first part. It's okay. We'll do that again. Okay. Yeah, sure. Yeah, you can follow along. So this is the code. Okay. So you can all get the cute fish right now. We load the image again and load it inside and make new objects by them. So we make a new jellyfish and we search for also transparent background. Yeah, we get a jellyfish. And we save it as jellyfish. Oh, jelly. And then we want to load it inside P5, so we upload inside P5, and we use our jellyfish image. Okay, so now we have the jellyfish, and then we make a new variable containing the jellyfish image. And we load it inside our preload function. So when your code gets longer and longer, always like you can close up those codes and just focus on what you're writing is much more easier. So we want to add something in our preload. We add jellyfish image as load image jellyfish.png. So you can try to like replace those images directly inside your addFish function, and you can replace that by jellyfish. It's a little weird. Yeah. And then we want to then use the same object both as jellyfish and both as fish. They are all like sea creatures. So we don't want to make the object again. So I would so there's a technique. Just add a type variable under fish object. So we are determining the type as a random picked by an array, whether it is fish or it is jellyfish. So the random, when you give random function an array, it will pick a random item from the items inside the array. So when you're generating a fish object, it will be a fish or a jellyfish. So you can observe that. You cannot see the change right now because they are still the same image, but if you see inside fishes, and you can open that, some is fish and some is jellyfish. So what you can do now is you can draw different image based on which type is that creature. So inside the drawing function, when you are drawing that fish, if this fish.type equals fish, we draw using fish image. Else, we draw using jellyfish image. So we replace this by fish image and replace this by jellyfish image. Okay, so now we have some jellyfish, we have some fish, they are happy, they are rotating. And we can make the scale a little smaller, so maybe just scale it down to 0.8, from 0.2 to 0.8. So they are more unified. And then the second part, you can give different motion using the same object. Like you can determine how you want to manipulate the data. So in the previous example, we use like fish will always move right, and fish angle is the noise function. So this should be only for the fish. So if fish.type equals fish equals what is that fish, we let the angle like rotating using our noise function. So you can see that if it is a jellyfish, it just stuck in that point because we didn't change any data at all. And then we can determine the movement. So else if fish.type equals jellyfish, and we can like let the jellyfish move upward and downward. And how we can achieve that is just like using the sine function for the y position. So for this one, we want the jellyfish to move upward and downward. You can imagine that its trace will be like this one. So we are still sampling at the point on this sine wave, and we can get the movement upward and downward. So we make it fish dot p.y plus equals sine frame count. So it'll be very fast because if you directly give a frame count, you can imagine that frame count 1, frame count 2, frame count 3, frame count 4, it'll like move in a very fast pattern. So you'll see the jellyfish jittering a little bit. And you can time this jellyfish by the angle, time the y by 10. So you can see that they are like kind of crazy jellyfish rotating in fish. And if you want, and we can make it more slower, just like divide the sampling point by 10. So you can imagine that what we are doing is like we make 10 other smaller points here, 1, 1, 1, 1, 1. So we separate those curves in a more detailed solution. So we can get the jellyfish moving, and we can make it slower, so just time it to 3. So we have 2 kinds of sea creatures, and we can also specify the. So if it is jellyfish, we want to like move a little, have a little random speed around. So if when we are adding a temp fish, we can determine the fish. So like if temp fish.type equals jellyfish, we let the velocity, we determine the velocity again, like overriding the velocity. So like tempfish.v equals random, v.x equals random 1 between -1 and 1. And also for y, we do the same thing. Okay, so we now get a jellyfish. And we also want that jellyfish, the position at equals velocity. So we change the position by velocity and also the sine wave thing. So these two effects will like overlap with each other. So the jellyfish will keep moving and keep waving. Yeah. And like for making the objects inside your range of the screen, we have to do 3 other things. So in addition to fish x over width, you have to detect if fish y over the height of the screen. So if fish.p.y equal bigger than height, then fish.p.y minus equals height. So you do it for bottom side, and also do it for if x smaller than 0. If it is at the left side of the screen, we add width to the x, and also if it is smaller than y is smaller than 0, we add height to the fish. So now wherever our fish are going, wherever our jellyfish are floating, they will always be trapped into the screen. And also some of you like may want to do like wave things or wave curves. So you can use begin path and close path. So if you want to do, we have fishbowl. It's like this. And we want to make this line. We can also use sine technique for this. So you can imagine that this curve is constructed by multiple points, and we can draw a line using begin and end shape. So what we can do is like we can for var I equals 0, I smaller than width, I plus plus. So when we want to make a line like this, we want to iterate all the points from the left side to the right side. The left side is 0, and the right side is width. And then we want to get this point on the line, so we get let y equals sine I. And before we use those points, so we use like begin shape and end shape. And we use vertex for constructing those points. And if you are not familiar with those things, you can get begin shape and end shape. So you can specify the x and y between those curves and those shapes to get the final result. So we use vertex, use I as the x, and use y as y. So we also want to give it a stroke, so stroke 255. And you can see that there's some curvy things up here. If we add an offset to y, it like adds height divided by 2 to y. We'll get the curvy line here. And if you want to make like the amplitude a little more, we can time this sine function by 10 or like 50. So we can get the sine wave here. And we can divide the sample point by dividing I by 110 or by 100. And you can see that the wave thing is like, you scale up the curve a little bit, you can see the details. And now we remove the fields, no field. So we can see this wave. And then if you want to add some movement to that wave, you can just imagine that we are sampling different points on the wave. So we are sampling here. We change this sampling point by our frame count. So we add frame count. It'll be very fast. And we divide it by 10. Or divide it by like 30. And you can see that the sine wave will be continuous moving. And you can change this actually to noise. So you can see that the noise curve is actually a continuous random. Are you okay? Okay, we'll stop by this point. Okay, so actually we are just visualizing when you can imagine that when the fish is jittering, the degree is actually get by some curve like this, and we sample a point on this curve, so it'll be continuous. And all the time, I will combine those two techniques. Like I'm using noise plus sine, so it'll be some part of this is noise, and some part of it, so like plus sine this. So you can see that in the bigger movement, it's still a sine wave, but in the smaller movement, it's a noise. Yeah. So we have our like cute fishbowl with jellyfish and wave. They are happy. So is there any questions? I think this is enough for now because we review rotate, translation, and scaling, and we do. So are you guys? Do you have any questions about you want to know about more or objects, vectors? Are you okay? Yeah. Just feel free to talk because I want to help you guys like get through the midterm, and I don't want to get too fast. Yeah, sure.
I can send it to you in the Slack.
Yeah, sure. Thank you. do you have this week? Okay. So okay, I see the homework. Okay.
Yeah.
Cool, cool, cool.
It's just a lot.
Okay, it's a lot. Okay. So you have to make two characters and then they should be interacting with each other and interact with the environment. Okay. So
There's a start chart that we can start doing.
yeah.
So maybe it's gonna be better. Like
Okay.
when I read through his like description, like he basically like he made something and we should change how.
So should we make sure
Yeah.
So you have the starter code for that?
Yeah.
Ah, okay.
Yeah, yeah.
Okay. Okay. So what homework do you have this week? Like other classes? So
So you need for this class?
yeah, for this class.
Ours is basically it's the same thing, like make something interactive.
Interactive
but
thing.
We don't have any limitations.
Ah,
It's
okay.
Like this, whatever we've learned, take it and do something with it,
Okay.
and then that's it.
Okay. Cool. So I think let's make two objects, and you can use mouse to interact with them, and you can make some like interactions between them, and also okay, let's make two using the same fish and jellyfish thing. Okay. This one? What is this? Okay. Okay, so this is okay.
That's what you show us in class.
Yeah.
Okay. So actually it's the same technical exercise. Yeah, so like add character and we make new objects and add it into an array. And okay. So they made some interactions within those items. Okay. Let us take a 5-minute break and I'll come back. Yeah. I have to get the charge. So we'll talk about like a little how to make interactive objects with the mouse and how to make them interact with each other in the next 30 minutes. Yeah.
So it says everything happened in the past 30 minutes? Oh, okay.
Thank you. Yeah, no problem. So we'll start at like 2:45. Oh, okay. Thank you.
But the lady is a son. I'm trying to test it. Yeah, they both bounce by themselves. Now I need one. It's supposed to be like every 5 minutes. Just sit like this. Oh yeah. Just the one size chip.
不一定是重力，就是速度。对对对，我没有给你，然后就一直往右。对。但后面还是讲太多。可是刚刚他们的饭就有了。啊。零object 吧，那叫。
有加个气的。
就还是。
肉萝卜呀。
I just wanted to see if it worked. I probably
Okay, so let's do the next second part. I decided to use the jellyfish and fish again. We want to make some interaction, so we want to make the jellyfish move with our mouse, and when the jellyfish approaches a fish, the fish will swim away. So I think that's the simplest interaction we can have right now. I think so. Yeah. So we just open a new sketch, and someone tell me they do not talk about objects a lot. So we will review a little bit about objects. So we still want our image file, so we add it again. We talked this for a lot of time, so we just upload it, and we get two image. And then we want to make a jellyfish object and fish object, and they can interact with each other. So we first we load the image. So var fish image equal and also jellyfish image, and you in function preload, and we can assign them to fish image equals load image. We load fish1.png, and we also get jellyfish image. It is jellyfish.png. So now we have these two images. We make objects for jellyfish and also fish. So we make two objects. An object is so like fish equals an object, And I often recommend you to like just define fish here and assign it after in setup function, because if you want to use some P5 digest function like random, like sign, you have to set up P5, and then P5 will run setup function, and you can get those functions using. So we assign fish equals a new object. So an object is using curly brackets, and it is combined with key and the value. So you can give it x is 5, y is something like that, y is something else, and also the value can be another object. It is nested structure. So we want to get p, and it is an object that contains x is 0 and y is 0. So this is same as the last session, and we can do another one that is jellyfish, and we assign it also. So jellyfish, you have p and also fish. You want to put the fish inside of in the center of the screen, so we initialize the fish position as width divided by 2, and also height divided by 2. And now in the drawing function, we draw the fish. So push and pop, I always do this two first to prevent any changes to the canvas. And we translate to the fish position. So translate to fish.x, .p.x, and fish.p.y, and draw out the fish. So image, fish image, and like 50 and 50. So translate fish image, fish image. Oh, we draw it at 0 and 0 because we translate to that point, and we give it the size of like 100 and 100. So you can see a fish here, and we want to align this fish to the center of the screen. So, oh, my canvas is a little too big. I make it 500 and 500. Okay, so now we have the fish, and we use. And then second part, we want to make another jellyfish object. So it is similar. We want to assign it to the mouse position. So in another push and pop, we assign jellyfish x equals mouse x, jellyfish.p.x. And also we assign jellyfish.p.y equals mouse y. So now if we translate to that point and draw the jellyfish out, and we draw it like using jellyfish image, we can get the jellyfish moving with our mouse. So is it okay to choose first? Okay. And then the third part, we want to make the jellyfish interact with the fish. So first we have to detect the distance between the fish and the jellyfish. So most of the time I would do it like most simple, just detect the distance. So using P5 P5 we can get, there's a distance function. So if you specify 2 points, you give it x1, y1, x2, and y2, we can get the distance between these 2 points. And then we can use this as the interaction. So if distance, we can log out the distance. So console.log, and we var a distance d equals to dist from this point. The first point is fish.p.x and y to jellyfish.p.x and y. So copy this and paste it here. So now we can use d as the distance, and we can get like if we open the console, the distance will be far here, and the distance will be like near 0 here. And now we can do some interaction. So we can observe the value. So it's around like 80 or 70. The fish is not nearly touched with the jellyfish. So if d smaller than 70, we console.log ouch, and we can get the result. So it's here, and we push get the fish. It's out. Yeah. So you can do something to your character if the jellyfish touch the fish, and we set something on the fish, so fish will like keep moving around or being crazy. So if in that addition to printing out, we set fish dot hurt equals true, and we have a hurt. So hurt equals false at first. So it is a happy fish at first, and whenever we touch the fish, it'll ouch, and we can check for the fish. So we can console get fish. What is fish? And we can see that instead of position, get hurt equals true. So what we can do is like, if hurt is true, we add some like random movement to the fish. So in here, before drawing the fish, if fish dot hurt, we can add some random movements like fish dot p dot x plus equals random 2. And also we do the same thing to the y, so p dot y. Oh. So like we touch it, it'll start moving. It's all creepy. Yeah. And you can also do something because the jellyfish also know it's touching the fish. So you can set jellyfish, like jellyfish dot win equals false. And you can set jellyfish dot win equals true. So if jellyfish win, it'll be like very proud and it'll scale up. And if jellyfish dot win, we scale to before we draw the fish. And remember that you have to translate to that point. So we translate to the place drawing jellyfish, and we scale up, so we will not mess up the coordinates and axis. So if it touches it, it'll be big and it'll scare the fish away. Yeah, so that's the first part. So we want to have multiple fish on our screen. So we want to make add fish as a function when you generate this fish modularly. So you can observe that we have fish object. We want to use a custom function, so we add a function add fish. And so we want to keep all the data for the fishes, so we need an array. So we will make another variable called fish array equals an empty array. So what we are doing in the add fish is actually we just copy this fish, and then we make a new fish. So like var temp fish equals this one. And then we add this temp fish inside the fish array. So we fish array dot add dot push this fish. Okay, so now we have multiple fishes and we want to draw them out, and we want to put it on random position. So we make the x to random width and y to random height. Okay, so we don't need the fish here. But before we remove that, we still want to do the same thing. We iterate all the fish inside fish array. So for var I equals to 0, I smaller than fishes dot length I plus plus, and then we make a variable let fish equals fishes I. So we pick a fish from the fishes array, and we set it as a temp fish. We can manipulate that fish, whatever it is. So we can move all the fish part inside. So move it inside here. Okay, so now we don't have anything in the fish array. So when we are like initializing our pen, we can like for var I equals 0, I smaller than 5, I plus plus, and we add fish. So add fish. Yeah. So we have something fishes started. Let's check. So we have some arrow. Fishes is not defined. I don't think fish is fish array. Sorry. So fish array and fish array. So we have multiple fishes inside our screen now. and it's not moving. Oh, because we have and translate to p.x. So we check again, and we see what's error in the console. We don't have p.x, p.y. Yeah, so we don't have p inside the array. Temp fish. So most of the time I just check the array to see if the variable is correct. So like fish array, we have 5 items, and they both have p and x and y. So that should work. So we should check for let fish. So we should remove the fish here to avoid interfering. Is it working? No. And you can, if you open console, you can click on those things, and you can see that which line has arrow. Okay. So it's here. So we detect fish position here. So we also have to move all this when we are using fish variables. We want to put it all inside our for loop. So we are getting the specific fish, not like the general fish. So now we have the fish, and we are moving. When we touch the fish, they're all moving around. Yeah, and we don't want this to do the scale up. Okay, so we can add a lot of fish, like we add 15 fish in the screen, and we move it around. They will all move and jittering, and we can make it a little smaller. It is a little scary, so we can move it around. Yeah. And also we can do something to the fish. They're weird. Okay. And when you're changing the size, remember to reset your distance to detect distance, so it will not be too sensitive. And you can also do like the put the fish back when it is outside the screen, and we don't do this again because we do that in this last sketch. And for the next part, you can do something like let the fish interact with each other. So the technique of this is like, give it 60 and make it a little bigger. Okay, I think that's enough. So just like checking the jellyfish and the fish, we want to iterate all the fishes. We get every 2 fishes inside the array and check for their distance. If they are colliding with each other, we just like letting them know they are colliding, and we can do something. So inside the fish array, we are iterating. We can let another fish. So we copy this for loop and copy the change this variable to O, and just avoiding they collide with each other. So we're still getting those fish objects inside this loop, and we let fish 2, the every 2 fish, another fish as fish 2. And we are checking when I is not equal to O, because what we are doing is like we have array of fish, okay. So we have an array of fish. So we using I to iterate those fish, and we are iterating it again inside the for loop. So we want to kind of make a contest, like testing this with this, testing them, testing, and testing. So we want to like check every 2 objects inside within these 2 within the array, like if they are colliding or not. So we don't have to check the same object. So when I is equals to O, that means we are checking the same fish. So we are going to like exclude this condition. So if we let fish 2 equals to fish array O, And if I is not equals to O, that means if they are not the same fish, we and we check for the distance. So just like checking the jellyfish and the fish, we do it again. So if distance of fish, we have to move this in the front so we can assess fish. So if distance of fish dot p dot x and fish dot p dot y, and also the second fish dot fish 2 dot p dot x and fish 2 dot p dot y is smaller than like 30, and we determine their colliding. So we set fish 1 dot collide equals true, and fish 2 dot collide equals true. So we know they are colliding with each other. So we want to do something to observe that. So maybe we rotate it like 180 degree, and we can see that they're colliding. So we add collide to the add fish function, and we make it false. And whenever they're colliding, we make it bigger, or we rotate it. So after we translate, if fish dot collide, we rotate 180 degrees. So rotate pi before we drive the image. So you can see that the cluster of the fish are the fish there that is colliding. And maybe you can like maybe just draw a circle around, like ellipse, 0, 0, 50, 50. So you can see that the colliding is happening here. When the fish is colliding, they will have an extra circle on their body, and you can see that the circles keep increasing because we didn't set the collide to false after they are not colliding at all. So we have to set else, or just like before all the things, you have to set before all the array, you use another for loop, and you drag out the fish array I to set the colliding equals to false. So that means we detect collide again and again each frame, so we will not like remain status from the last frame. So you can see that if they swim away, this one be collide for a little while, collide. And we also want to move the image mode to the center, so image mode center. So the collide circle will be on the fish. So you can see that if they are colliding, you can see the circle around. Yeah. And what you can do with this is like if they collide with each other, they'll kind of scare each other, so they will swim away. So you can add a velocity just like we done in the last sketch. We like v equals to 0 at first, like x equals to random, like 1, and y equals to 0. And we add p to v, so we update the position with their velocity. So we also do fish.p.x add equals fish.v.x, and fish.p.y add equals fish.v.y. Okay, so they're kind of swimming, they're colliding with each other, and we can still scare them. And if they're colliding with each other, we want to like reverse the direction of the velocity. So if fish dot collide, we want to reverse the velocity x, so velocity x equals negative velocity x. Oh, so they kind of stuck, and because they are like keep changing directions. And we can change that like by just if they are colliding with each other, we add something to the velocity x, so random negative random 2, they will swim away. So you can see that when they're colliding, they will swim like, they will try to like escape from each other. And also you can scale it up, so if it is colliding, And scale 0.8. Or maybe we can rotate it, like rotate sine frame count divided by 10. So you can give them different movement when they're colliding with each other, give them different like actions, and setting the status on that fish object. Yeah, and there's another technique if you want to add something continuously, like when you press down the mouse and you want to release the mouse, and during the process you want to you want to add a lot of fish, you can, if mouse is pressed, this is a very useful function. You generate the new fish, so add fish. And because add fish didn't set a random variable, and if you want to set it to mouse X and mouse Y, I would recommend it to just add a parameter like X and Y, and I will use like X or random width, like in Y or random width. So using this OR symbol means that if you didn't assign any value inside the parameter, it'll use the second value. So you can imagine that we are not specified the position yet. So when we press the mouse and we release the mouse, it'll be in the random position, but we want it to be in mouse X and mouse Y. So when we are specifying the parameters, and this one will, the X and underscore X and Y will get value, and we will pick the first value inside this. Otherwise, it'll pick the random width. So we can see a lot of like fish waving around. And it'll be very slow if you like calculating those two pairs again and again. So try to avoid like adding too much, or try to remove those items when it is like outside of the screen. Yeah. So you can observe that if you add a lot, you're like kind of stuck in, and you will your pen will like, your computer will blow up. So just remember, you can, so if we can add a variable called that if it is open, it is over the boundary of the screen, we call it that, and we don't calculate everything for that. So like that equals false, and if it is over width, so checking fish array, if fish dot p.x is bigger than the width, we set fish dot dead equals true. And then for those like colliding condition, we don't calculate them. So if fish is not dead, so is not fish dot dead, we calculate the colliding condition for that. So it'll be much more smoother when like fish get outside of the screen, we get back our speed again. And we can have like random, because they're hurting from the jellyfish. Okay. So yeah, so that's how you can make interaction between different objects and add some status change to the object to determine whatever your character should do. Yeah, so that's so we just add some random thing, like random 100. So they will not collide with the jellyfish. So, yeah, so that's how you make objects interacting with each other. So I will send this code to Slack here. So now is the open question session. If you have any questions about your homework, you can bring it up here and we can discuss it together. And if you are interested in others' questions, maybe you are using some techniques also, you can just like follow the explanation.
Can we use like, can we make an object in which we define it as an image?
What's happening?
Like, can I define like, if I'm doing the fish thing,
Yeah, sure. So if you want to define an image into your X and Y, into your object, you can, most of the time I will make, we have a global object here, and I will add fish and make an image and using like giving it directly to the object.
Okay.
And we can use this image for drawing, so
So now when we use the object, you have the
yeah, so we can use like fish object. And you can like change that image with whatever you like. So if we go jellyfish, we'll get jellyfish, a lot of jellyfish. So that's other questions about the sketch or about other things you're using? Oh, so if you want to run your p5.js thing in your local host, in your own file system, it's much more easier just to use VS Code. I'm a VS Code user, so download and save it, and you can get a zip file. And then in the zip file, you can open it by VS Code. So VS Code is my favorite text editor, and we have a very useful plugin called Live Server. So you can download VS Code here, and then you open the folder by VS Code, and then you can see all your files here. And to run the server, if you directly open that, open the HTML file by your browser that just broke, because the image is not served by the local server, the program don't know where to load the image. So you can install a plugin called Live Server in VS Code, and after you install that, so I uninstall that and install it again, and then you can see a tab open with Live Server in your VS Code. So after you open with Live Server, it will just work. So that's how you can open your sketch in your local file system. And if you have a bigger sketch, you want to do some file management, just remember to use whatever text editor, but I'm using VS Code. That is much more easier. Yeah. And for like VS Code, there's a lot of like useful features like multi-select. You can select like our jellyfish code. So you can right click and there's like prettify things, or you can select fish and you want to modify this at a time. So select and Command D, you can select them all, and you can modify them at the same time. So that's a useful concept. And also I will install some plugin, like there's p5.js snippets, so that will like, if you like typing background, good. Yeah, so whatever you're typing, like it'll show some like p5.js standard variables for you to use. And also I will install like random indenting and like change some font, but that's additional content. Yeah, if you are interested, you can check with me. And so that's how you can run your code in your own computer. So anything else, or any questions about your homework? Any other? So the rest of the part, I will be here till 4 or 4:30 and just work on your own things. And if you have any questions, I will be here. Thank you.
把所有的人称堆在一起，然后互相读 ID。
对。